All right, guys. Good morning. It's Coach Osborne. I'm going over the day 2 section in your packet. So if you guys look in your packet, you'll see day 2 right here, input output machines 1.1.1. I'm going to be going over these notes. After I go over this page and the page after that, your homework is going to be this page right here where it says homework 1.1.1. Okay, so turn to this page right here. Oops. Which says notes. All right, so when we talk about inputs and outputs, when you look at a function or equation, you're going to plug something in and then you're going to get something out. That thing that you plug in is going to be your x value. The thing that you get out, we call the y value or the output. Okay, so input, output. All right, so now if I'm looking at this one right here, this machine, what's happening is I'm going to take that 3, x equals 3, I'm going to plug that in to this function, x squared minus 1, and then I'm going to get an output. Okay, so how do I set that up? Well, I take this function, and I just basically plug in the 3 right there where the x is. I replace it, and notice what I'm going to do. I'm going to put parentheses. Wherever that x was, I'm going to replace it with parentheses, and now put the 3. And notice again, the x is gone, right? I don't rewrite the x because I'm replacing the x with that 3. So now I want to simplify that so I can find the output. 3 squared is 3 times 3. That's 9. Then minus 1, that's going to be 8. So that is the output or y that we were looking for. So what is the output? 8. Okay. Next question is, what if the input was negative 6? Well, I do the same thing. I replace the x, I put negative 6 squared minus 1. But notice again, I put the negative inside the parentheses. That's really important. If you don't, then you'll forget that you got to square that negative, meaning you have to do negative 6 times negative 6, which is a positive 36. And even when you type that into a calculator, you need to make sure that you put parentheses around the negative. Otherwise, it will not square that negative and it'll make it negative. All right, then 36 minus 1 is 35. So then the output for negative 6 is 35. Okay. All right, so now that this one, we have a new machine. Okay, in this machine, it's going to be negative x divided by 2 minus 10. Okay, and before we work with the inputs and outputs here, I also want you to notice that there's a negative in front of the x already, right? So I'm going to actually rewrite this and show you kind of what it looks like because it's a little small. Negative x over 2 minus 10. That negative in the front is actually like a negative 1. So when I plug in that x, I need to multiply negative 1 before I divide 2. All right, so let's go ahead and try that. So now if the input is negative 2, what's the output? All right, well now what I'm going to do is write negative 1, put parentheses wherever that x is, right? So I replace the x. Now I'm going to put in my output. Okay, negative 2. And now I got to think PEMDAS. So first I got to work out the top of the fraction. So negative 1 times negative 2 is going to be positive 2. All right, now I have to divide before I subtract. 2 divided by 2, and that's 1. And then 1 minus 10, that's negative 9. So the output's negative 9. Okay, and then I do the same thing here. I want you guys to try it on your own and see what you get. Okay, so now I plug in the negative 1, just like we did before. Sorry, I plug in the 8, just like we did before, over 2. Okay, negative 1 times 8, negative 8, divided by 2. Okay, that'll give me negative 4. And I got 2 negatives, so they're both negative, so I add them up, so I get negative 14. So negative 14 is my output there. Okay, so now, again, you guys try these two, or try this one. Try it on your own. All right, so now you can see that I plugged in the negative 10. I simplified there and ended up with negative 5. Okay, so now it says what is the output, or if the output is 6, what is the input? So all these other questions you basically had an input, right? You plug something in and you got something out. Whereas now they're telling you what you get out, but they're not telling you what you plugged in. So you actually have to work backwards to figure out what you would plug in to get positive 6. So instead of plugging in that 6 into the x, I'm actually going to make this function or this machine equal to that. All right, so what I'm going to do is I'm going to set up negative x over 2 minus 10 equals 6. Because again, I'm looking to see what number do I plug in here to get 6. That's the difference. So if you're given the output and they want you to find the input, you're going to work backwards here. All right, so first I'm going to solve this just like an equation. So first I got to go to this side. Here's x, right? That means I need to get rid of this 10. So I'm going to add that to both sides. That cancels out, becomes 0, 16. Now I just have negative x over 2. All right, so now what I want to do is I want to get rid of this negative and this 2. And remember, this is a negative 1, right? So if I've got a fraction being multiplied times x, what I can do to get rid of that is multiply its reciprocal. Reciprocal means the same thing upside down. So 2 over 1, but I need to get rid of the negative, so I also need to multiply a negative 2, or a negative as well. So now I'm going to do the same thing over here, negative 2 over 1. Now I want you to notice something. Negative 2 over 1 is literally just negative 2. It's not, you don't need the 1 technically. All right, so what happens is the negative 2's cancel out, and the 1's cancel out. Okay, and now I'm left with x. And then here, I can put this over 1, and now I just multiply across. 16 times negative 2 is going to be negative 32, and it's just 1 on the bottom, so I don't need to write that 1. Okay, so then I end up with negative 32. Okay, so now down here, this is all the same thing. So now I'm going to plug in that 3, wherever the x is. Okay, and then simplify. Okay, so first I got to do exponents. 3 squared is 9. 20 minus 9, that's 11. Okay, same thing here. 112 minus the x. Again, just replace the x with parentheses right there. Okay. Again, I'm just kind of emphasizing that's what we're plugging in. Okay, so I'm going to put 12 here. I don't have to square anything, so all I have to do is subtract those two numbers. So 112 minus 12, I got to do that first. And now I'm going to do square root of 100. Well, what number do I multiply twice to get 100? Well, that would be 10. Okay, now this is called a rational. A rational just means it's basically like an expression that looks like a fraction. Okay. So it looks like a fraction because I've got like one expression on top of another, right? Kind of like you have a number on top of another for a fraction, or like over here. So these are just called rationals when you have that. All right, so again, wherever you see the x, I'm going to write those parentheses, right? So on the top and on the bottom. In other words, I'm not going to just plug in this input once. I'm actually going to plug it in twice. Plug it in here and here. Okay, so now what I do is I do the top first. So 5 plus 3 is 8. Then I do the bottom, 5 minus 7. That's going to be negative 2. And then I divide those two. So 8 divided by negative 2 is negative 4. Okay, so now, again, same thing. Determine the outputs from each of the function machines. Now notice what's happening. I'm plugging in this 1. I'm going to get something out, but now what this is telling me to do is take this input and now plug it into the next equation. So whatever I get from here, I'm going to use that number as the input for the next step. Okay, so first let's do this one. So 3 times negative 1 plus 1. Okay, so 3 times negative 1 is negative 3. Plus 1 is going to be negative 2. Okay, so now that negative 2 now becomes the input for the next machine. Okay, so now I take that negative 2 and plug it in. Okay, so first I plugged in the 1. Okay, now I'm going to take that negative 2, and now it goes into the next machine right there. And all I'm doing is negative that number squared. That's going to end up being 4. Okay, so the output of both of these machines after I plugged in -1 ended up being 4. Okay, so now here, given the input is -1, find the output of each expression. Okay, so that means for all of these, I'm just going to plug in -1. So -32, and then this one, I'm just going to put in that -1 here, and then here 1 over that. Again, it's going to be the same input for all 3 of these expressions. Okay, so first 4 times -1, -4. -4 minus 32 is 36. And now it's asking, what's the input? Well, you plugged in -1. What did you get out? You got -36. Here, -1, there's nothing to multiply, so it's just -1 minus 2, which is -3. -3 squared, or -3 times -3, is 9. What did I plug in? -1. What did I plug in for all of these? -1. All right, so this output's 9, and now I'm going to do this one. All this is 1 divided by -1, which is -1. So you end up with the inputs and the outputs end up being the same there. Same thing here. You're literally doing the same exact expressions, but now you're plugging a 5 instead of a -1. So I want you guys to work through these on your own and see what you get. All right, so this last one, go look through. Did you do the steps correct? Again, on this one, we end up with 5 minus 2, so it's 3 squared is 9. Remember, all the inputs are the same. This last one, you end up with just 1 over 5. And 1 over 5, I can't divide 5 into 1. And I can't reduce this by dividing either one into a common factor. So that's all I got is just 1 over 5. I end up with a fraction. All right, so that's it. So remember, after you guys watch this, I want you guys to complete this homework assignment, this one page, and make sure that is done for Monday when I see you guys next week.